Hi, welcome to our webinar on generative AI. Today, we are talking a little bit about how generative AI can work in organizations to help them create value, as well as how to actually build these generative AI solutions on a more technical level. My name is Tennyson, and today we're joined in the studio by Eva Bosma, the practice lead of generative AI at Xebia, and Krzysztof Kąkol, Chief of Data Engineering at Xebia Poland, as well as AWS Ambassador and AWS Community Builder. Welcome to the both of you.
Thanks. Happy to be here.
Thanks, Krzysztof. Eva will help us with her expertise on the more business side of things in terms of organizations creating value from their generative AI solutions, and Krzysztof will be helping us on the more technical side in terms of how to build these generative AI solutions. So generative AI has been around for a while, but I remember it becoming a lot more popular around 2022 when it became a lot more user-friendly for regular people. I just want to confirm my understanding of generative AI because I hear it a lot these days. To confirm, it's some sort of tool where it takes in text inputs from you, so you prompt it with natural language text, and then as outputs, it can give you jokes, poems, or advice on where to go on holiday. Is that correct?
A bit, yeah.
Okay.
So I think you're partly right. I think what's good to highlight is that generative AI is also capable of generating anything else except for text. So we've seen that it can span several modalities, ranging from videos to images. And of course, we've seen the classical example of also generating code.
Wow. Okay.
So I think that's a small adjustment to your explanation.
Oh, thanks very much, Eva. Thanks. I didn't realize it was so powerful and so versatile. I've also heard a lot about LLMs, or large language models. What can you tell me about them?
Yeah, so a large language model is a model that is basically trained on a really large corpus of text. So imagine a model that has been fed all the information that is available online, for example. And what it does, it's just predicting the next best word in line. So imagine you are typing on your phone. Sometimes you get a suggestion for the word, what might be the next word. And that is basically what an LLM does. If I really simplify it, of course, in my explanation. So it's just telling you what's most logical in a range of words that have already been provided.
Thanks, Eva. Krzysztof, would you like to add on to Eva's explanation in any way about LLMs?
Sure. Of course, from the business perspective and from the user's perspective, it's what LLM does. But sometimes there is a question: why actually the LLMs are called like that, large language models? So I usually explain that because they are trained on a huge corpus of text, and all the connections between words are basically detected and evaluated. So what you end up with, the large language model, is a big mesh of all words in the dictionary connected with each other with a certain number, which is significant for the model. So you can imagine a big ball of words from the dictionary, and the connections go from each word to the other word. And what is more, the connections, the values assigned to the connection depends not only of these two words, but also on the context in which these words occur in the training corpus. That's why the LLMs are so good at predicting the next word, but they don't usually, or they don't always have to predict the most logical word. It depends on your setting. It might predict something that is unusual and thus becoming more creative.
Thanks. So to confirm, the LLM is not actually understanding the language and thinking through rational thoughts to create you the most optimal answer for you. So you can't ask it to build you a billion-dollar company directly, or ask it to solve world peace. So it's just predicting the next word.
If your question is about does the LLM understand the world and the rules of the physical world, no, it does not. It's just a prediction of the best word in the context to simplify things. It's not that simple, but understanding it like that is like a very high level. In a very high level context is quite good.
Ah, cool. Thanks to the both of you for that explanation then. Then in that case, it sounds like there are some risks and limitations to LLMs, no matter how cool they seem to be. How are organizations able to use LLMs effectively?
Yeah, so within Xebia, we see 3 types of levels if we talk about LLMs. So level 1 is what we call clever prompting. That is just asking a really smart question to the system, providing it with the right context, making sure that it can, as Krzysztof just said, make the best estimated guess for the next word in line. So answer your question, that's it. We also see that we can take this a step further, having a level 2, wherein we force the LLM or the model to base its answer on a data set that we gave the model. So instead of just providing the next best word in line, it will give an answer based upon a certain data set or database that you have used or ingested into the system. And then if we take it another step further, we see a level 3, which we call connected agents. And this is where we not only ask the LLM to provide an answer or give a certain output, but where we also ask it to take a certain action, execute a certain task. And I can elaborate on that, but we have Krzysztof online as well, and he can explain this in much more detail later on. So I will leave that teaser for now.
Thanks, Eva. It sounds like there's lots of different types of capabilities then. And before we dive into each of them on a more technical level, I'm curious about level 1 with the clever prompting you mentioned. To me, clever prompting just sounds like something I would do by myself, just wording my instructions more carefully. What is it really, and how can organizations really get a lot of value from clever prompting?
Yeah, good question. So we see this happening in different business examples. So I just add one to the slide wherein, for example, an email is being sent to a customer support desk. And instead of a customer support colleague needing to read through that email, we ask the model to already extract all relevant pieces of information from that email. So it can not only summarize it, for example, but also eliminate all the irrelevant pieces of information. So imagine you're a travel agency. As a customer support agent, you get a lot of emails every day. And most people who are going on holiday are, of course, excited. Hey, I'm super excited to go on holiday. And they add a lot of text information in that email that might be irrelevant. So an example of how clever prompting can play a role here is where we say, this is the email, this is the relevant piece of information that I need to actually create the booking for this user. Please just extract all pieces of information. If something is missing, let me know. Making it very fast.
Is it always 100% accurate then? It seems like it's a bit risky if along the extra information from the customer, it maybe could miss out something. I don't know.
Of course. And that requires a lot of testing. So in the example I just want to show in a minute, we had 100% accuracy in 50% of the cases. So
in 50% of the cases. Yeah. Okay. Now that sounds more reasonable.
But of course, it's always good. And I think that's a whole other discussion. But do you want to do something fully automated, or do you want to keep a human in the loop? I think at this point, it might still be wise to keep a human in the loop. But in other cases where impact is less risky, you might go with a fully automated solution.
So it sounds like there are a lot of complexities also on the business or organization side as well.
Yeah.
Krzysztof, could you maybe show us or talk about how someone could build something like this on a more technical level? A very simple example, of course.
Sure, but what I would like to show you is how Bedrock comes into play here. This is a service from Amazon, and it looks like that. And Amazon Bedrock is exposing quite a lot of models for the people to use in different cases, in different use cases. There are lots of vendors like A21 Labs, Amazon itself, Cloud, Command, and a couple of more. There are not only LLMs, because, for instance, Stable Diffusion produces so-called diffusion models, which are different from LLMs, and diffusion models are used to generate images. But anyway, you can use these models under a single umbrella, so to say. So you have a single API, consistent API, which gives you access to multiple models, and you can adapt your use case or use the relevant model for your use case. You can also, for instance, play around on the Amazon's playground. So you can pick one of the models. For instance, we'll pick Titan text, and you can set up different parameters here. For instance, this is the most interesting one. This parameter called temperature indicates how creative the responses should be. If we go something like up to 1, then these responses will be very creative, and for 0, it will be very so-called deterministic. And you can talk with or discuss with the model on different things to see how this model actually works in your case. Because as Eva said, the clever prompting has multiple different applications, like generation of text. This is simple, but also summarizations, but also extracting informations, like in the case presented by Eva. The thing is that all these models are good, but some of them are better at different types of applications. And then in Amazon Bedrock, you can pick one which is actually relevant and great at your use case.
Cool. Thanks, Krzysztof. I noticed you make it look really easy to use Amazon Bedrock. How much of that is your own deep skill set, and how much of that is actually just easy for most people to get started, at least?
Well, I think that there are two layers of that, because the first layer is what most of us have touched upon, like the existing applications where you can play around with any models from different vendors, not only in Bedrock, of course. But the second layer is how to use it programmatically. Because at the end of the day, if you have to summarize a short text, you can put the short text into a prompt and make a clever prompt. Well, this is not super clever, actually, but saying, please summarize this short text for me with maximum of, 200 words. This is simple. But if you have a long text, which is over the available context window, so-called context window, which is the maximum length of the text which you can put as a prompt, then you have to chunk the text, so make some fragmented, and you have to summarize each fragment and then each piece of this text, and then make a summarization of the summarizations. So basically, some of the technology used under covers is not very complex, but requires programmatic approach, which requires actually some skills for the clever prompting. What is more, the clever prompting itself is an art, because there are various approaches how to prompt the model to get the relevant result. There are many approaches such as zero-shot prompting or few-shot prompting, and different other types of prompting that will give you the correct answer when you expect it. It's not that simple as it looks at the first glance.
Thanks, Krzysztof. So it sounds like it's easy to jump in and start, but there's a lot to learn to really get a lot of value out of these sorts of solutions.
Exactly. Especially when you expect the good responses, or the responses should be relevant to what you expect. Because the thing is, like with this example, with extraction information from the emails, you can make a simple prompt that will extract this information, but at the end of the day, you require, like in this use case, you require a consistent, for instance, JSON file that contains all the information that you would like to extract from this email. And obtaining this consistent JSON is not that simple in using the available models.
Cool. And then just thinking again for different organizations, because different organizations have different sizes. How expensive or how cheap is it to start playing around with these generative AI solutions on something like AWS?
Mm-hmm. Well, starting to play around with these models is usually quite cheap, because you actually pay as you go, so you pay per million of tokens for every model. It, of course, the pricing depends on the model. The differences might be huge sometimes, but it's simple to start and really inexpensive to start. But then when you reach a certain traffic or you have complex tasks to do, then it might get expensive, but that's where actually our consultants come into play and help to optimize cost, help to set up the proper strategy for using the large language models in a business.
Thanks. Okay, I see why our colleagues are so important here. I think some people still might be curious, though. I know it's difficult to put an exact number on it, but in terms of a broad scale, in euros, when you say it's cheap to start, is that in hundreds of euros, thousands of euros per month when you're starting out? Not when it's live, just experimenting.
No, well, it's not that scale. I mean, if you are making a POC on your own and you have your own AWS account and making a couple of approaches to do some even complex tasks, it might be a couple of dollars per month or a couple of euros per month if you use it wisely. Sometimes it's a little bit more expensive because if you go to level 2 and 3, then you probably require some additional infrastructure for that, which might be expensive. But this is just for the start, of course. If you have thousands of users using your chatbot created with LLM, it might be really expensive. And you have to consider some additional scenarios, like setting up your own model in your custom endpoint, or maybe purchasing so-called the provision throughput in Amazon. It might be a good place or a good moment to evaluate different solutions to approach to cost optimization in that case.
Cool, thanks. So it sounds like then while we're still playing around and just building a proof of concept without thousands of users yet, with level 1 capabilities, what about level 2 capabilities? Can we find out more about them?
Yeah, exactly. Let me start with an example. I already briefly elaborated on what a level 2 is. We call them search index integrations. I think these days they're also called, among a very good group, a user group, Retrieval-Augmented Generation solutions.
RAGs. Yes, I've been hearing about RAGs.
Yeah, I think it's quite common now. So before, and what I said before, it's really forcing the model to base its answer upon a certain, closed-off data set. And when is this relevant? I think we've seen so many cool cases where this solution can play a role. That's the same infrastructure or the same way of working, but applied to different industries. Take, for example, healthcare. If you have your drug leaflet, I don't know if you've seen it, but for aspirin, I think it's like huge. And sometimes it's really hard to extract the relevant pieces of information from such a drug leaflet. So we said, what if we can chat with a drug leaflet? So there's just a chat interface. The drug leaflet is in the database underneath, and the system will answer your question about a certain drug or medicine that you're taking based on all the medical information that the provider in this case has added to the database. And this is very, very explicit for healthcare, but also think about policies for insurance or banks who have like huge, big pieces of information that you have to go through to, for example, get a loan or name it. Every organization that works with lots of information that can be quite complex, I think such a solution works quite well. And I've added one on the screen, which is a searchable and chattable database for insurance documents. And I do want to show you a small video.
Yes, please.
Wherein, and this is just a demo, but it really shows, also a brief sneak preview behind the curtains, because what we do here is we upload to insurance documents. They are added to the system. Once they are ingested, we can chat with these documents. So we can ask a question. Can be anything. In this case, what are the risks associated with a certain loan? The system will give me an answer. And to make it a very trustworthy solution, it will show me in the source document, highlighted in yellow where it actually found that piece of information. So what if we're now asking another question? It might show or the reply based on the source document, or in this case, hey, that's a great question, but I don't have the answer in my database available. Do you want to upload another document? This is for demo purpose that we do that. Of course, if you have to have a customer-facing tool, you might not want to do that.
Yeah.
But I think it's quite nice that it's making a solution much more trustworthy.
Yeah. And I like that it helps people in terms of it saves time. You don't have to read through the documents yourself. But it does feel like you still would want people involved in most cases, because sometimes it could just link to a part of a document, but is it actually super relevant to your question?
Yeah.
It's nice to see the source and check, oh, this answers it perfectly, or maybe I need some more information, or it's not clear.
Exactly. And I think what you see now, like, could you summarize the conversation so far as final question in this demo? That is also what Krzysztof highlighted. A clever prompt, which is the final question, is basically allowing the tool to just summarize what has been said before. So this is, I think, a really good example of how we can use the search index integration, so the level 2, but also keep that level 1, the clever prompting, in place.
Okay, so you can still use level 1 in level 2, and I assume then in level 3.
I hope, but let's dive into level 2 a bit further, because it looks very easy in this demo, but I'm certain, Krzysztof, that you can also elaborate on, that it's maybe even easy from a technical perspective. You can answer that question.
Yeah, because clever prompting seems relatively easy to do on a technical level. This sounds a bit more complicated, and I think you mentioned that a bit earlier.
Yes, well, the clever prompting is usually or is always used at every level. And in fact, on level 3, it gets really, really complicated to force the model. Of course, it's a simplification. I will comment on that later. But to force the model to call external services to get additional information. So the better the prompt is, the better the results are. For instance, consider the example that Eva showed right now, is that at the end of the day, you have to gather the information or get the information out of the existing documents. And it might be used, and it is usually used in that context using the so-called semantic search. So you're searching for a semantically valid information in the provided documents. But what if we would like to evaluate if these returned contexts, returned documents are actually relevant? Because we know that the model returned these documents. Well, this not the model returned. We usually use specialized vector stores to do that. But how to validate or how to evaluate if the returned documents are really relevant to the question? Because that's the point. And then you have to write additional prompt to evaluate that. So still you are working on the level of prompts because you are forcing the model to return you the concrete information about the provided documents. So clever prompting is everywhere.
Cool, thanks, Krzysztof. Is it possible to see a little bit of a technical demo for search integration, level 2?
Sure. I see on the screen the basic diagram of the architecture, which is showing how this information goes through. So generally speaking, you can create a knowledge base within Bedrock, and knowledge base orchestration tool gives you mainly 2 opportunities. The first opportunity is to create a vector store where you store your information, for instance, these policy documents. And the second thing is the request to the LLM to return a response of that. And Bedrock is basically orchestrating the flow for you, so taking all the heavy lifting. The same thing happens in the level 3. What you have to only do to create the knowledge base is you have to provide the documents which are the source of your knowledge, and Bedrock does all the things for you. I have a demo of how that works, and I'm playing the video right now. So you have to start with creating a knowledge base. The name is totally irrelevant here, so you can omit everything, and then you have to select the data source. Here are the two examples of two books, Shawshank Redemption and Silence of the Lambs, and you then pick the right chunking process. The chunking process is required here because you have to be aware that the models have a limited context window length, and you cannot basically find the relevant context using the whole book. It's because the representation of the content of the book is numeric in the database, in the vector store. And the longer the text is, the more the so-called vector is, we call it diluted. So it does not contain numerically any sensible and reasonable semantic context here. So what Amazon is doing, what Bedrock is doing, is it's chunking the book into parts. You can control the process of chunking yourself, but I picked the default chunking to not complicate things more. Then you have to select the proper embeddings model, so the numerical representation of the text, and the correct vector store, which is by default OpenSearch serverless. And then I'm waiting a couple of minutes for the knowledge base to be prepared, and that's all. Then I have to synchronize my data source. Whenever the data source changes, I can synchronize it again. And then I can just test it using the selected large language model. For instance, this is the sample of using Claude 2. And the first question is, who is Andy Dufresne, who is the main character of Shawshank Redemption. And we can see not only the response from the model, but also the references, which were also presented on the policy example. So we can not only see from which parts of the document that the response was created, but also which sentences of the response were created from which chunks. And the second question, who is Hannibal Lecter, who is the main character of the Silence of the Lambs? Again, the response is correct with the proper source chunks. And that's all. Amazon Bedrock simplifies things. But it's not always that simple. This is just an example of books which have a consistent content without any points and breaks. Of course, there are chapters, but that's not super important here. But if you have more detailed documents or more complex documents, then you probably have to struggle with chunking yourself to get the relevant answers, because the default chunking will not work well in these use cases. And I would say that 50-60% of your effort will be to chunk the documents correctly, and there is a huge experience needed to create that or chunk it correctly to make the knowledge base working great.
It does seem that this is being executed quite fast. Is it that easy to set up a RAG architecture in Bedrock?
Yes, of course. It's like you have to wait a couple of minutes between some steps. I've cut in the video, the waiting times are cut, but it does not take something like the movie is 1 minute 43 seconds, but it all took in real life, it took something like 5 minutes to
that's
create.
Not so bad.
And of course, the time needed to create the knowledge base depends on how large your data set is. But basically, it's that simple.
Okay, wow, very cool. Thanks, Krzysztof. That was a really great demo. It's nice to see that there are some extra steps compared to clever prompting, but in terms of the capabilities, it sounds like you can do so much more in lots and lots of different industries across lots of different use cases.
It's more controlled. You have more. Yeah, it's more trustworthy. You can just scope it a bit more to tailor your needs.
That's really, really helpful. Then I wonder.
And again, one more thing which is super important here, from the programmatic level, you have access to these knowledge bases as if you used the normal AWS API. Well, actually, you use the usual AWS API. So I've shown the example in the AWS console, but you can obtain the same result when speaking with the bot using simple methods provided by the AWS API. So it's really, really simple to try and implement things, simple solutions.
Okay, yeah, that's a nice way to conclude the demo and the discussion about level 2 capabilities. Thanks very much, Krzysztof. So it's simple to try, but difficult to master, is what I'm hearing.
Oh, well said.
So then what about level 3 capabilities?
Level 3 is what we call the connected agents. So as said in the beginning, it is not only the LLM providing an answer, but most likely also taking a certain action. Imagine having a workflow. There are several steps within that workflow. And in this case, the LLM is also capable of executing the next activity or the next task. I have to say that even though we believe that this is indeed the next step after level 1 and level 2, I haven't seen it that much in practice yet. So it's still a bit, I don't know, Krzysztof, if you have a different experience. I've seen it a few times, but not that often, especially not in a production setting.
I think it exists on the market, and there are a couple of implementations of using the connected agents out there. But the usual problem with this, or the usual challenge with the connected agents, is to find a good use case for that. And typically, many years ago, people developed chatbots helping people, to order a pizza or doing some other things that required the access to some dynamic external endpoints using the services like Amazon Lex. So these services allowed us to build intent-based chatbots before the era of GenAI. And now the connected agents get into this field as well. So we are able to build an intent-based chatbots using GenAI in a much, much simpler way than it was done before. Because the difference between connected agents, the real difference between connected agents and RAGs are that RAGs use the static knowledge provided by us before the question was asked, and the connected agents are able to answer the questions which require the dynamic request for the knowledge. For instance, imagine that we have a bot that is able to answer what is the weather in a given part of the world. We cannot put that into the vector store because it's too large, and it should be dynamically replaced every hour or every 5 minutes to make it precise. So the idea is to make a bot that is able to call the external weather service to get the proper weather information dynamically on demand.
Cool. I think in the Netherlands it might have to be called every 5 minutes because sometimes it just suddenly starts raining and then I'm
it's simple. The answer is it's cold. Yeah, always.
Yes, but sometimes it's suddenly cold and wet, and then I have a problem when I'm outside.
Yeah, and in a business context, we see, of course, knowing what the weather will be. That's, I think, buienradar is quite well known in the Netherlands, of course, but there are other tools that you can use. Just to continue from the travel agency I just mentioned, the example of if you use connected agents in such an example, you can, and let me quickly start this video, take that, for example, a step further where you automate the booking process. Oh. So within this chatbot or chat interface, as Krzysztof just said, you can ask relevant information, get the information that you need to actually complete a booking. But if you have a connected agent, you could also automate that booking process, stating, hey, I now have all the information that I need. Do you want me to make the booking for you? And just by replying yes or confirmed, the system can automate your booking and you will just get your tickets in your mailbox. And that sounds, of course, amazing. And I think, we can also speed up many different processes with this technology. It's also good to highlight that, as said a few minutes ago, if we eliminate a human in the loop in such processes or use cases, that there's also a risk involved. And that requires, of course, that we monitor quite well that the model or the solution is indeed acting as should, and that no mistakes or limited mistakes are being made.
That
and that
makes
is, of
sense.
course, a tricky part.
Yeah, I see again where the lots of experience and expertise comes into play. It's easy to build things and experiment in some cases, but then to actually build something that's solid, stable, and valuable sounds like it takes a lot more work and a lot more expertise.
Yeah, it sounds easy, but it comes with a lot of complexity now and then. Yeah.
Speaking of the technical complexity then, Krzysztof, could you explain a bit more how level 3 capabilities, these connected agents, work on a more technical level?
Sure. So let's show the example of the architecture. And this basically shows that Bedrock is again taking, like with level 2, taking all the heavy lifting for us. So it's orchestrating the process of getting the knowledge, of running the external endpoints and returning the response. So in Bedrock, you can create an agent which not only calls the external endpoints to get the weather or to get the information about possible travel destinations, like in the demo presented before, but you can also attach a static knowledge base, which is a typical thing. For instance, you can create a knowledge base that returns the information about the ticker symbols of all the companies which are present on NASDAQ to get additional information from dynamic endpoints. And in this example that we showed before, the knowledge base is not used. We only provide a couple of external endpoints, and one endpoint is responsible for getting the information about all the available offerings or available destinations. The second endpoint is responsible for getting the information about the details of a given offer. And the third endpoint is responsible for sending the booking or for creating the booking and returning the tracking number of that booking. And again, it's about clever prompting, because in fact, what you have to do is you have to provide the model the information about what kind of tools are available for the model to make things. Actually, the model is not doing these things. It only says what to do, what to call, what to request. And normally, you would have to implement all of that yourself. In Bedrock, you just create a smart prompt, which is a basic one, saying what this bot is about. And then you provide an API and a description of that API, and it basically works. I can show you quickly how it's created. It's very simple and very fast.
To try out.
I was about to say.
Yeah. So basically, if you go into agents, so what you have to create initially is you have to create a Lambda function which has these endpoints available. So here is the endpoint returning the destination details, the available destination, and to make a booking. This is just a simple thing. It's some so-called a mock Lambda, which does only simple things, does not connect with any database, but normally you would do that. And what you have to also do, you have to provide a description of that API, which is so-called an open API format, which says, for instance, that this tool or this endpoint gets the list of all available offers. Why you do that? It's because you provide that information to LLM, which is responsible to solve your task. How you do that? You create an agent, you put a simple name, you can set up some additional informations like roles, permissions, encryption, and these kind of things, but they are not important right now. You pick the model and you enter the instructions. For instance, like that. You are an agent that can handle bookings for selected offers. First, present available offers to the users, then let the user select an offer and present details of it. Next, ask the user if the offers should be booked. If yes, create a booking and return the booking details. And some additional things like to avoid returning the information about the provided tools and these kind of things. And that's all. Once you create a good open API definition and provide a working API, that's everything. You have to, of course, inform the agent where the endpoint is. So this is a Lambda function, and where the actual schema exists. So the definition in OpenAPI format. You can omit the knowledge base. In this case, it was omitted because the agent can also orchestrate connecting with an existing knowledge base. And that's all. Basically, at the end of the process, what is returned is the demo that was presented before. That's all.
Cool. Thanks, Krzysztof. Again, you make it seem very easy. I'm assuming this is a very simplified example, and it gets more complex.
Yes, it is. It is very simplified example. You probably sometimes have to include some additional rules for the process or for the agent to not do things that you would not like it to do, like return the toxic content and these kind of things. But what is important that Bedrock creates the system, so-called the system prompt. So it has all the information inside, and what is more, the agent also makes a classification. The Bedrock agent makes a classification of what you say to it. So for instance, if you say something toxic, something irrelevant to what the bot is able to do, it will respond to you that it's not able to help you. So it's validated before it does anything under covers, and all of this heavy lifting is provided to you by Amazon Bedrock.
Sounds very convenient.
Yeah.
Very cool. Thanks. Before this webinar, there were some parts of generative AI that seemed a bit more like magic to me. But after these discussions and seeing things in the technical demos, I think it starts to make more sense in terms of why there's so much hype. Because actually, there's a lot more that's possible with generative AI than I think a lot of people thought initially. So
you can use, for instance, because we've spoken just as an example, we've discussed things with semantic search, but you can imagine that it's possible also to make a semantic search using images. So you have a library of images, but you're using a multimodal model that can search semantically in these images, not in the text. So it might be really helpful if you have a company which has a library of pictures and you would like to search for something without even tagging it before.
Very cool. We've seen a lot of what's possible today. How much are different organizations using these different levels of capabilities? How much are they actually getting value out of these generative AI solutions?
I'm going to give a very annoying answer, but it depends.
Okay,
so, of course, level 1 is something that everyone can play around with. Every chat interface where you can ingest a clever prompt, you can play around with. So that's used quite often. Level 2, that's something that we see happening more and more. Instruction manuals, insurance policies, drug leaflets, many different industries that are now using this technology to make complex data accessible to everyone in an easy format. Level 3, I've seen people playing around with it, also organizations. I would say at this point it's still a bit a dot on the horizon, and we see standard tools and solutions popping up, really creating something from scratch, as Krzysztof just showed. It is being done, but not yet on a really large scale as far as I've seen. And how much value is in there, that's always dependent, of course. Is it faster? Is it better? Is it cheaper than the old situation? That depends.
You make a good point. Yeah, and I guess we're still relatively early on in this technology, so things I'm guessing into the future will become much better, much cheaper, more capabilities might be unlocked. I know it's a bit dangerous to predict the future or look into the future, but maybe off the record, no strings attached. Any speculations from either of you about what you guess might be coming up in the future, or how things might evolve in the future?
Well, I think that the technology will evolve for sure. Everyone thinks that probably the prices of GPUs used for the models will be cheaper, so the models will be cheaper as well. But in fact, I see a trend to develop so-called small language models, which are a little worse quality than the large language models, but much smaller, so cheaper to develop, cheaper to deploy and use on your own infrastructure even. And the second trend is task-specific models. So the models, large language models that are pre-trained for some specific purposes, like healthcare, for instance. Both of these approaches are very vivid on the market right now, and there are lots of companies doing that. And it might be useful for us to think about the future, because people are excited about the new versions of different types of models that are even better than the previous ones, and they're greatly solving difficult tasks. But in fact, at the end of the day, if you're creating a bot for your company, you're paying attention to the price. And well, that's why, for instance, small language models arise. Again, there are various tasks, not only bots, like summarizations or semantic search, where different types of models can be used. And I think that in the future we will have a lot of these kind of variations of the models, and lots of types of models that are applied to different types of tasks, not only language connected. For instance, the large action models, which are able to perform some external actions as well, or large vision models, which are applied to videos and images to perform some other things. So, well, the scientific effort is huge towards speeding up how the models work, and towards, of course, creating maybe new architecture of the neural network, which will absolutely change the landscape, like the transformers changed the landscape in 2017, but in fact, from commercial perspective, last year.
Very cool. Thanks for indulging me and my curiosity. So then if people want to find out more about how to create valuable generative AI solutions, where should they go, or what should they do?
That's an easy question to answer.
Right.
No, of course, we can support in different areas. So we see that we have offerings ranging from what can you do with the new generative AI technology? How can you make sure that's valuable within your organization? Because most important, we can think about solutions, but it's great to actually bring them to production. And we have amazing colleagues on board who can support in that, from ideate to scale to train the user, of course, on how to use it effectively. So, they have to run to Xebia, of course.
Cool. Sounds great. Thanks very much, Eva and Krzysztof, for your time and your expertise for this webinar. And thanks to you, the audience, as well, for spending time and watching the webinar as well. Thank you for watching, and I hope you found this webinar really enlightening. I hope you have a great day. Bye.